Hello students, welcome again. I am Ashwini Kumar from Department of Applied Sciences, David Chalandar. Today I am going to give you a lecture on numerical methods to find roots of algebraic and transcendental equations. My root. In the regular Falsi method as compared to bisection method. So bisection method works on finding bisector. Regular Falsi method works on the methodology of finding root with the help of intersection of chord with the x-axis. Suppose A to B is my bracket. Then the point AFA and BFB, we will evaluate one chord between these 2 points, right? So this chord intersect at x-axis. The point is called the new approximation. So suppose C1 is my point at which the chord cuts x-axis, then the value of C1 will be A into FB minus B into FA over FB minus FA. So I will show in the next slide that how this we can obtain this, right? Now again, you in the similar pattern as we have done in bisection method, if f of a into f of c1 is negative, then I will replace b by c1. That means my new bracket will be, yes, a to c1, right? But if it is not so, then my new bracket will be c1 to b, right? So in the similar pattern as you have done in bisection method, you will find c2, c3, c4, c5 and so on till you get the two equals values of C. So when you get the two equal values, that will be your root. So this is the methodology of regular Falsi. So let us try to get the formula for this C1, that how this formula arises. So before that, just look at the graphical view how regular Falsi method works. So see, this is our bracket, initial bracket from left and from right. So what we have done, at this point AFA and at this point BFB, between these 2 points I have drawn the chord. So this chord intersect at C1 with the x-axis. So this C1 becomes my new approximation and this is my formula. So we will derive it later. Now C1, at C1 you can see clearly the value of function is negative. So what we will do, similar like bisection, we will discard the previous negative value. So my new bracket will be C1 to B, right? Now again at C1 and FC1, this point is C1 FC1 and previous my point is BFB. So between BFB and C1 FC1 I will make the new chord. This chord will intersect at C2, right? So this chord will intersect at C2. This C2 will be my new approximation. In the similar way, we will find C3, then we will find C4, then again we will approach to the root. So this is the methodology of regular Falsi method. So it uses the methodology to find it intersection point of the chord with the x-axis. So this is the methodology of regular Falsi. So this is the derivation you can formulate for regular Falsi. I have used two types of formulation. So suppose this is my bracket AFA and this is the next point BFB. So this is the chord and let this chord intersect at x-axis the point I have given the name D, right? The initial points are at A, I have taken the name of point as A, and for this point I have taken the name as B, right? Now you can see for easy approach I have construct one AC and BC lines, vertical and horizontal lines. Now from this figure you can see A, B, C, this triangle, yes, and this triangle AEC1. These two triangles are right angled triangle, right? Here angle A is common, this angle C is 90 and angle E is again 90, right? And these are parallel sides. So between the parallel sides the third angle will be same. So with the help of AAA similarity in the lower classes you have studied, the triangle ACB and the triangle AED both are similar. So you know the similar triangle in the similar triangles the ratio of the corresponding sides is equal. So I have used that idea. So AE base and the base of the bigger side, bigger triangle AC. AE over AC, the ratio of AE over AC is equal to the ratio of their perpendiculars, means to say the ratio of DE and BC, right? Now just simply write the values AE. What is AE? It is C1 minus A, right? Now what is AC? What is the value of AC? AC is B minus A, right? So I have just substituted all the values. What is the value of DE? What is the value of DE? DE is what? The value of DE is minus of FA, right? Why? Because this is the same height as the point of FA, right? So this is minus FA. Now in the similar way, what is the value of BC? BC is FB minus FA. Clear? So I have substituted all the values and I will get the value of C1 from the formula. So this is one methodology. In the other methodology, I have used the concept of geometry. Similar point AFA and BFB. The line, the chord passing from AFA and BFB, that means the line passing through 2 points, the equation is y minus y1 equals to y2 minus y1 over x2 minus x1 into x minus x1, right? So I have applied that formula, and now just see this point D, that is C1, lies on this chord, right? So substitute this point on this line, you will get the value of C1. So in exam you can use any of the methodology to show the formula for regular Falsi method. Both the ways are correct, right? Do any one. A less preferable method. Now same example I am going to proceed with the regular Falsi method. I am going to solve it with this method. So again initial guesses are, I have taken same initial guesses so that you can see the difference between them. Same initial guesses, A is 3 and B is 4. So first iteration, the value of C1 is 3.2857, right? Again at 3.2857 the value of function is negative. So what to do? Previous negative is this 3. Previous negative is this 3. At 3 we have function's value is negative. So replace 3 by 3.2857 in your second iteration, right? So this is your negative value and this is your positive value. Again find out C2. Clear? Now again f of C2 is negative. What to do? Again replace the previous negative value. So previous negative value is 3.2857. So replace 3.2857 with the 3.3137. So my new bracket is 3.3137 and 4, right? So again find C3 and so on. Find these all we have summed up in this table. You can see first value is 3.2857, second value is 3.3137. In the similar way all the values I have found and collected and made the table. Now you can see the value of this C comes to be equal in 6th and 7th iteration. That means regular Falsi in 7th iteration gives the result. as compared to bisection method. Now you can compare yourself. Bisection method takes 14 iteration for a question to find root of 11 and root, whereas regular falsi is taking only 7 iterations to converge the same value. So that means number of iterations are almost half, right? So this is up to you that which method you have to apply in the exam.